Assalamualaikum and greetings. Today we are from Group 6 with presents on engineering maintenance, inventory control and resource management, which all topics covered in Chapter 3. First, I'd like to introduce the members of my group. Muhammad Nazmi, our only boy member, is in charge in this group, together with 3 more stunning ladies, Nur Atira Laili, Nur Hazira, which is myself, and Shaida Nafisa.
What is maintenance? By adding a maintenance package to your hire agreement, you will benefit from our dedicated technical team who will support the maintenance of your vehicle during the lease period. Our maintenance agreement covers all mechanical and electrical repairs and replacements that you may need due to fair wear and tear, and even includes parts and labour. This also covers any services and MOT tests you should need, as well as replacing and fitting tyres that are worn or punctured. You are additionally covered for items such as batteries, exhausts, wiper blades and cam belts that you would expect to wear out, so you don't have to worry about unexpected maintenance costs on these routine items. And by choosing to lease with Lease Plan Go, your agreement will include AA breakdown cover for home and roadside assistance. You will be able to manage all this via one telephone number called Driver Line that will help you to arrange all work that is required, as well as organising collection and delivery of your vehicle for services and MOTs at a time that is convenient for you.
So first topic is maintenance engineering. We will begin with the fundamentals. What is maintenance? It is the act of preserving or maintaining someone or something, or state of being maintained. In other words, it is a set of activities that are carried out to keep equipment in a specific predetermined state or to restore it to the original state. So in engineering, maintenance is the discipline and profession of applying engineering concept for the optimization of equipment, procedures and departmental budgets. It is to ensure a reliability, availability of equipment and to perform their function at optimum condition. In maintenance, there are 2 important definitions. First, maintenance policy. It is a statement of concept that utilized to help maintenance management and meet its goal and make decision. Second, maintenance management. It is described as the organization of maintenance in line with the set of guidelines. Maintenance management is divided into 2 types of function, primary and secondary. In primary, the management have to do maintenance of existing plant equipment, inspection and lubrication of equipment, utilities, generation and distribution such as electricity supply, water, gas, and lastly, new installation of equipments and buildings. Meanwhile, in secondary, management focuses on plant protection such as firefighting, wastewater disposal, pollution, sanitization, and storekeeping. The objectives of maintenance is to keep maintenance cost or production item produced as low as possible. It is also to maintain the product's high quality so that it can be used as its best. Besides, it also to minimize the main equipment downtime to a minimum so that no time is wasted and the equipment may be used soon. The objective of the maintenance is to provide and maintain appropriate facilities and also to provide effective and trained supervision.
People often question the importance of maintenance. but let's take a moment to see the results. See the difference? I think we all know which one we'd rather visit, shop and work at, send our children to, or even live. Lack of maintenance coupled with age, general wear and tear, and the effects of weather can significantly affect the image of your business or site. Refresh, rebrand or maintain with Programmed's professional maintenance programs. Our long-term maintenance programs will keep you looking good and professional all the time. It's something we've been doing since 1951. A long-term maintenance program prolongs the life of your assets and ensures your site and brand presentation is growing traffic. Upgrade facilities for a new look or complete smaller projects as part of this for a site you'll always be proud of. Whatever your industry, we'll help you maintain not only your property but also your brand, so you're driving people to you, not away. But what is stopping you? Cost. Maintenance can be expensive. We get it. That's why at Programmed, we make maintenance simple. We provide options to address any possible situation and let you tailor these for maintenance that's suited to you. Get work done when and how you need it. And choose a payment schedule that works for you. Planning a major redevelopment or refurbishment? The Classic program allows you to make the biggest impact without the full associated upfront costs. Payments are evenly spread out, although most of the work is completed now. The Choices program is suitable where there are remaining funds in an annual budget or when paying from an established sinking fund. Most of the work and payment is concluded up front with smaller subsequent payment amounts. Use the Multi-Form program. Address maintenance of assets according to their specific needs or condition with an even distribution of payments. Asset already in good condition? Retain that high standard of presentation with the Safeguard program that pays for work as it is completed. Whether you need painting, grounds maintenance, signage, fit-outs or building services, audio-visual, data communications, reactive maintenance, golf courses, sports turf, ovals or a range of other services, easily combine multiple services into a single supply stream. National coverage, local delivery, comprehensive services, all in one place. So why not talk to us today to see how Programmed can empower your organisation? It's that easy.
Engineering maintenance. Type of maintenance. There is 3 types of maintenance, which is corrective maintenance, preventive maintenance, and breakdown maintenance. So today I would like to share with you, which is about preventive maintenance and breakdown maintenance. Preventive maintenance. Preventive maintenance is the process of maintaining equipment and assets on a regular basis in order to keep them running and avoid a costly unplanned downtime due to unexpected equipment breakdown. A successful maintenance strategy requires the planning and scheduling of equipment maintenance before a problem occurs. An effective preventive maintenance plan also includes keeping track of previous inspection and equipment servicing. Many companies use preventive maintenance software to organize their required preventive maintenance, thus due to their difficulties of keeping a preventive maintenance schedule for a large number of equipment. Step in organizing the planned preventive maintenance. First of all is we have to establish the responsibility. Second, we have to planning and scheduling the work. Third is we have to prepare the work order. Fourth is we have to inspection and testing. Five is we have to record and keeping. And lastly, we have to evaluating the effectiveness and corrective action. Preventive maintenance should cover this following item, which is non-destructive testing, periodic inspection, pre-planned maintenance activity, maintenance to correct the defects found through testing and inspections. Advantage of preventive maintenance. There is 4 advantages. First is improve the productivity. According to statistics, lack of maintenance can reduce a company output capacity by 20%. You can avoid this drop in output and reduce the downtime by following to the maintenance standards, resulting in increased efficiency and productivity. Second is the greater equipment lifespan. By guaranteeing that equipment operate according to the specification, you can extend the asset's life. Falling apart reduce the life of your equipment, causing costly repair or replacement. Third is improved safety. Maintaining asset help to avoid potentially harmful failure, reducing the risk of injury and subsequent liability lawsuits. This will make the worker work in the safe environments. And lastly, reduce costs. Operating a piece of equipment to failure is expected to cost 10 times as much as undertaking routine maintenance. The cost is result of unplanned downtime and repair. You can schedule necessary repair or part replacement at the convenience time by understanding the maintenance requirement, whether you can do it yourself or need to hire a professional. Type of preventive maintenance. There is 4 types of preventive maintenance, which is first is time-based maintenance, second is users-based maintenance, third is predictive maintenance, and lastly is prescriptive maintenance. Time-based maintenance. It can be helpful to create a monthly or annual maintenance schedule that complies with the manufacturer's recommendation for inspecting and cleaning equipment to keep you on tracks. Even outside of this recommendation, you should keep in mind that the most essential equipment to your business should be checked regularly to ensure that the best possible operation. Example of calendar-based maintenance might include servicing your air conditioner a month or 2 months from summer, replacing salt for soft water system, and cleaning van to completely with health standard at least twice per year. When creating a time-based preventive maintenance plan or deciding what to add to it, consider the major utility, equipment, tool, and technology that your business depend upon for success. This should be checked on regular basis to ensure that your business continue to thrive. The last thing you will want to do is close for several days due to a problem that could be prevented with a bit of planning. To support time-based maintenance, it's also a good idea to keep detailed notes about previous breakdown and problem with tool and equipment, so you will have a better idea of which system and equipment might be need a bit extra care. Users-based maintenance. If your business uses certain machinery or equipment every single day, it's a good idea to track users, which is their equipment monitor, operating hour, and production cycle. Especially if the equipment does not automatically produce ticket or notification when a certain number of operations hour has been reached. This is referred to as use-based maintenance. Whether it is physical oil change or essential piece of machinery that has reached X number of hours, staying on top the proper care and maintenance will ensure long-lasting use in important equipment. Predictive maintenance. Predictive maintenance rely on the sensor to capture information from the equipment, such as temperature sensor or vibration sensor, and if generally specific to technology that can trigger work order if a machine or appliance is in need of a inspection or upgrade. Predictive maintenance entails monitor the condition of essential machinery to track the performance and to detect the possible defect that could be result in the system crash. This type of preventive maintenance might be especially relevant for manufacturing, food production plant, power and energy industry, where the information gleaned from the predictive maintenance will allow for maintenance manager to predict where system downtime may occur based on the previous pattern and to schedule the maintenance tasks to reduce the crash on the critical operation equipment. Prescriptive maintenance. It is similar to the pattern that predictive maintenance analysis. Prescriptive maintenance use the advanced analytical, machine learning and artificial intelligence to generate the prediction about the maintenance and also act on them. What does that mean? Basically, the prescriptive maintenance make the recommendation to improve the system operation and also follow up on its own to produce a work order and oversees the entire process. Some advanced, that is because some advanced, that because it is probably some advanced, that because it's probably is for most business. Some advanced, that's because it's probably is for most businesses as long as you are manually checking your extension equipment and staying on the top of manufacturers' recommendation and inspection procedure. You're already well on your way to especially preventive maintenance. No prescriptive maintenance required. Breakdown maintenance. Breakdown maintenance is performed on a piece of equipment that have been broken down, has a malfunction, or cannot be operated in any other ways. The purpose of breakdown maintenance is to restore the functionality to anything that have been broken down. Preventive maintenance, on the other hand, is done to keep something going. It is something done as a result of an unanticipated, even if a crucial piece of machinery fails. For example, maintenance is undertaken due to the pressing necessary for the machine to function again. Breakdown maintenance, on the other hand, can be planned ahead of time, which is what we call good breakdown maintenance. Type of breakdown maintenance. There is two type breakdown maintenance, which is planned maintenance and unplanned maintenance. Planned maintenance. Planned maintenance is implied that the company is prepared for a breakdown and even anticipated it. The equipment continues to run until it fails, triggering a run to fail RTF triggered. While RTF triggered can be happen at any time, breakdown maintenance program use RTF to save maintenance costs. This type of plan must be meticulously documented and monitored. Employees should be aware of which parts are likely to fail and which will be maintained typically through the preventive maintenance. A breakdown maintenance plan can be manipulated or go awry if certain inspections are not performed. An example of planned breakdown maintenance is run-to-fail maintenance, where organization has been decided that letting a piece of equipment break down before receiving it the most cost-effective and less destructive option. Unplanned breakdown maintenance. Unplanned breakdown maintenance, on the other hand, occur when a piece of equipment fails or breaks without warning, often known as unplanned downtime event. While some of facilities may not have a planned maintenance program in place, almost all facilities require resources for unplanned maintenance. After all, every piece of machinery will fail or break down at some point throughout its lifetime. Example of unplanned breakdown maintenance is corrective maintenance and reactive maintenance. Corrective maintenance is performed when a breakdown occurs between scheduling preventive maintenance occurrence. Reactive maintenance is performed if a breakdown occurs because of a maintenance strategy has not yet been put in place. Example of breakdown maintenance. It is unique in its application because it cannot be used with certain industry or products, especially one that involve health and safety. This means that it is most frequently used when the part of inexpensive or non-essential. Here is some example which breakdown maintenance is applicable, which is first is equipment cannot be repaired at all, in which is mean that inaccessible, designed or designed to not be repaired. Second is assets consist of inexpensive or easy to replace part. Third is non-critical pieces of equipment, which is like hand tool. Fourth is object or equipment that are disposable or meant to be replaced at the end of their lifespan. And lastly is a short life assets, which is battery and high flow pump. As you can see from this example, it's become available when there's no inherent safety risk to letting a part of or a pieces of equipment break. As an example, consider a facility's light bulb. If light bulb is not linked to a safety features, it does not make financial sense to replace it before it has burned out. However, it is absolutely not viable when people's life can be endangered by a part of or a produce breaking. For example, the aviation industry cannot rely on the part breaking down to fix them because doing so could threaten the personal well-being and safety of people on planes. This is also true for a tire manufacturer who are responsible for road safety. When it comes to the people life, preventive and predictive maintenance are the right choice. Advantage of breakdown maintenance. So, failed equipment can lead to distorted consequence, but a clearly documented maintenance plan can actually have a few significant benefits for the organization. First is minimize the maintenance costs by cutting out an unnecessary preventive maintenance. Second is lowers cost of replacing disposable item frequently, like light bulb, tool, and fuse. Third is downtime for repair is consolidated. Fourth is low staffing needed. And lastly is simple and easy to understand when maintenance is required. Disadvantage of breakdown maintenance. The downside of breakdown maintenance are especially important to weigh given the nature of the maintenance plan. For example, breakdown maintenance should never be used with safety equipment because a single lapse can cost one of multiple employees their health and their life. First is form of waste in manufacturing environments. And second, safety issue can occur with unplanned failure. Third is can be costly depending on part of failure. Fourth is required careful planning and execution. And lastly can be difficult to pinpoint source of issue. Keeping track of previous inspection and equipment servicing.
Hi, welcome to Education Leaves. In this video, you are going to learn predictive maintenance. The topics I am going to discuss are: what is predictive maintenance? How does predictive maintenance work? What are the advantages of predictive maintenance? What are the disadvantages of predictive maintenance? Let's start the video. Predictive maintenance is one of the types of maintenance that monitor the condition and performance of equipment during normal operation. By doing so, maintenance managers and technicians are able to identify possible defects and fix them before they result in failure. In fact, 91% of manufacturers who deployed a predictive maintenance program saw a reduction in repair time, as well as a 9% increase in equipment uptime, and a 20% extension in the life cycle of aging assets. Similar to preventive maintenance, predictive maintenance is a proactive strategy that aims to eliminate asset breakdowns. But, unlike preventive maintenance, predictive maintenance tries to predict when equipment might fail, with the use of IoT devices and sensors. This allows maintenance frequency to be as low as possible, to avoid a costly reactive strategy. If you want to know about preventive maintenance, check that video in the description. Now come to, how does predictive maintenance work? The first step in practicing predictive maintenance is establishing baselines. You need to monitor the asset's conditional baselines, and collect data before installing sensors. That way, when you begin to collect conditional data, there is a control to compare any abnormalities to. To effectively collect the right data, predictive maintenance programs have to be paired with the right condition monitoring technology. In particular, a CMMS and multiple IoT-enabled devices. The Internet of Things, or IoT, plays a key role in the process of forming an efficient predictive maintenance strategy. By collecting the necessary data from condition monitoring sensors, IoT devices can take the data and connect it to a maintenance management system. From there, it's simple: anytime a piece of equipment performs outside of normal parameters, the sensors trigger your predictive maintenance protocol. Typically, a work order is generated in your CMMS, and assigned to technicians so they can perform any required repairs to address the anomaly. The information captured by predictive maintenance sensors can vary depending on your equipment and machines. Examples include infrared imagery. Through the use of infrared cameras, technicians are able to detect high temperatures for worn components such as electrical wiring. Acoustic analysis. It's seen as a cheaper alternative to ultrasonic imagery. Acoustic analysis helps to detect liquid, gas, and vacuum leaks. Vibration analysis. Sensors can be used to determine an increase or decrease in the vibration of essential components such as pumps and compressors. Oil analysis. It allows engineers to constantly check the condition of a machine's oil lubricant and determine if it has been compromised by other particles and contaminants. Now move on to what are the advantages of predictive maintenance. 1. Minimizes unplanned downtime of mission-critical assets. 2. Reduces time spent on maintenance. 3. Increase the life expectancy of machines and equipment, in some cases by 20 to 40%. 4. Reduces machine breakdowns and unexpected failures. 5. Minimizes costs spent on labor, spare parts, and equipment. 6. Reduces stock of spare parts due to increased service life of assets. 7. Improves safety throughout the workplace for technicians and operators. What are the disadvantages of predictive maintenance? 1. Detailed and time-consuming planning to ensure this maintenance approach is deployed throughout each facility and details all assets. 2. Purchasing the right condition monitoring equipment, which can result in high upfront cost. 3. Hiring skilled staff or training maintenance teams, which can be expensive. If you want to read in details, or download the PDF, go through the link in the description. Like, share the video and don't forget to subscribe to my channel.
Hey guys, my name is Ryan and I'm the founder at Upkeep, and today we'll be going over what is predictive, preventative, and breakdown maintenance. So first, let's start off with what is preventative maintenance. And so just very broadly, preventative maintenance is maintenance that's regularly performed on a piece of equipment to lessen the likelihood of failing. So preventative maintenance is typically performed while the equipment is still working so that it doesn't break down unexpectedly. All right, so let's see an example of this. We've got an HVAC machine. And so typically on an HVAC machine, there's some set of rules for preventative maintenance. And one of those could be something like replacing the filters every 6 months. So there's a lot of good and bad also associated with preventative maintenance. These types of preventative maintenance and inspections allow you to find issues before they occur and also allow you to schedule these repairs before it causes an issue. Now, the bad thing about this is that it could be a little bit more costly than you would like. Sometimes you wind up over maintaining a particular piece of equipment, but most of the times it's better that you do that than wait until something is broken down to figure out that, hey, we need to maintain something. Next up, we've got breakdown or reactive maintenance. And just again, very broadly, breakdown maintenance is maintenance performed on a piece of equipment that is broken down and is unusable. So it's based on this maintenance trigger. It's either planned or unplanned. Typically, this could be something that stops production, that's we have to run to fix. And a good example of this is same going with that HVAC machine. If we've got an HVAC machine, a breakdown maintenance example would be your HVAC machine stops working, and we need to call a technician to come fix it. So why is it good? Why is it bad? Well, typically a breakdown occurrence is not ever really good. Typically a breakdown maintenance can stop production and become very costly for you and your facility. So we want to try to prevent as many breakdown maintenance occurrences as possible. And so lastly, what we have is predictive maintenance. And predictive maintenance allows you to help determine the condition of service equipment in order to predict when maintenance should be performed. And again, this approach typically promises cost savings over routine or time-based preventative maintenance because tasks are performed only when they're needed. And let's see an example of this, of predictive maintenance. Going back to that HVAC, we've got sensors installed in this HVAC machine telling us the operating efficiency. and also the expected efficiency that could tell us when we need to replace those filters. So over time, obviously, those filters become clogged, and if we have sensors in this HVAC machine that tell us the operating efficiency, we can see exactly when it becomes more cost beneficial to us to replace those filters. And so why is it good? Why is it bad? Predictive maintenance is typically more expensive to set up than just waiting until something breaks down, which is literally zero setup, and also a little bit more expensive than doing preventative maintenance, at least in the short term. On the long term, however, predictive maintenance allows you to approach maintenance only when it's needed, so that you can see trends over time and track when something should be maintained. And this really helps out with not over maintaining a piece of equipment on a scheduled basis. And that happens quite often because we're not always sure whether it's 3 months, 4 months, 2 months to create a preventative maintenance work order. With predictive maintenance, we can see exactly when we need to have that maintenance work order generated. And so yeah, thanks so much for watching. That's kind of the breakdown between preventative, predictive, and breakdown maintenance. Thanks for watching.
Predictive maintenance. So what is predictive maintenance? Predictive maintenance techniques help determine the condition of in-service equipment in order to predict when maintenance should be performed. So predictive maintenance is a proactive maintenance strategy that uses condition monitoring tools to detect various deterioration signs, anomalies, and equipment performance issues. Based on those measurements, the organization can run pre-built predictive algorithms to estimate when a piece of equipment might fail, so that maintenance work can be performed just before that happens. So, the goal of predictive maintenance is to optimize the usage of maintenance resources. By knowing when certain parts will fail, maintenance manager can schedule maintenance work only when it is actually needed, simultaneously avoiding excessive maintenance and preventing unexpected equipment breakdown. So, for example, they might service a vehicle once every 6 months or after every 50,000 miles. So, for a machine in a factory or at an oil or gas plant, they might carry out maintenance once the machine has reached 10,000 hours of operation. This is a better approach than guessing when maintenance should occur or even worse, waiting for a failure to happen. So why are equipment, machine and vehicle failure important? In industry like manufacturing, maintenance caused by a failure is known as unplanned downtime. Unplanned downtime is very costly as there is lost output and productivity that can have an impact deep into the supply chain. Research found that 3% of all working days are lost annually in manufacturing due to faulty machinery. Planned downtime for maintenance is the better option by considerable margin. With planned downtime, maintenance can be scheduled when it will have the least impact on maintenance. So, the objective of those responsible for maintenance is to schedule the work in a way that prevents failure from occurring as well as to optimize the usage of maintenance resources. So, there are several key elements to predictive maintenance with technology and software. First, the Internet of Things (IoT). Artificial intelligence and integrated systems allow for different assets and systems to connect, work together, and share, analyze, and action data. So next is predictive maintenance workflow and example. So how predictive maintenance workflow? Connect sensor to asset and then collect data from sensor. Next, identify baseline and set parameter. Then run as usual. Sensor detect performance anomaly and then create work order and perform maintenance. And then it will run back into run as usual after perform the maintenance. So next, the example of predictive maintenance will based on the pump motor. So a centrifugal pump motor in a coal preparation plant is a vital asset for day-to-day operation. To prevent unscheduled downtime, the maintenance team decide to use predictive maintenance technology. Because the pump motor is a large piece of mechanical equipment that perform heavy rotation, the obvious choice is to monitor vibration with vibration meter. So and then, the team attached a vibration meter close to the pump inner bearing and establish a normal baseline measurement. Visualized through a waveform graph, a few months later the vibration meter identified a spike in acceleration. The maintenance team reviewed this new data remotely and scheduled an inspection. The technician who performed the inspection find a loose ball bearing and repairs it. And then, moving forward, the team connect the vibration meter to its computerized maintenance management system (CMMS). Now, when the same spike is identified, a fault with the ball bearing is predicted and a work order is automatically triggered to perform the repair. So that is how the predictive maintenance works. So basically, how predictive maintenance work is we need to first monitor the asset condition baseline, then collect the condition data so that there is a control to compare any abnormality to. After that, predictive maintenance has to be paired with the right condition monitoring technology to effectively collect the right data, for example, computerized maintenance management system (CMMS) and Internet of Things (IoT). Therefore, whenever any piece of equipment performs outside the normal parameter, the sensor will trigger the predictive maintenance protocol. In CMMS, the work order is generated and it will be assigned to technicians so that they can repair the faulty equipment. So next is the advantages of using predictive maintenance. First is it reduces time spent on maintenance. Second, minimizing the production hour lost to maintenance. Third, minimizing the cost of labor, spare part and supply. Fourth, increase the life expectancy of machine and equipment. And lastly, enhance safety in workplace for technician and operator. Okay, so next we will be watching a video about predictive maintenance of pump system and also example of predictive maintenance solution by using IoT system.
In today's technological climate, many industrial processes are left to pumps, and our reliance on these pumps means that downtime simply isn't an option. But what if you were able to predict pump failures before they happen? With Grundfos's predictive maintenance method, we can do exactly that.
So Grundfos is the largest pump manufacturer in the world, and predictive maintenance is a key part of the future of how we want machines to be maintained. Predictive maintenance is taking a look at the equipment while it's in service and understanding exactly when it's going to need maintenance so that you can time it appropriately to maximize the efficiency and effectiveness of your maintenance program and operation.
For our customers, it's becoming more and more important that their pumps work at all times. Breakdowns cannot be tolerated.
We operate the third largest wastewater plant in the state of Wisconsin. We treat 36 million gallons a day. For the last 90 years or so, we've been able to clean and treat that wastewater to some of the highest standards in the world. If we fail, if we shut down, the wastewater that is generated continuously, day to day, hour to hour, minute to minute, would then be dumped into rivers and streams and Lake Michigan. So failure is not an option here.
Grundfos's comprehensive sound dictionary of mechanical malfunctions delivers real-time diagnostics and actionable insights that are sent back to the user instantly.
Every mechanical system around us emits noise, so different malfunctions have very unique patterns that we learn how to recognize. And we do this by connecting sensors to the machine that have vibration and ultrasound capabilities, as well as record temperature and even magnetic emissions. And we then send this data to the cloud, to our servers, where we apply the machine learning algorithms, the AI. So we listen to these machines, right, with our sensors. And by comparing this recording to all the previous recordings, we can detect the slightest change, and we can even tell you what's wrong with it.
Our ability to function while the plant or factory here is running constantly, shutting it off is not an option, and that's very critical. They need to be functioning when we need them at all times on all cylinders.
In short, predictive maintenance tells you where a potential issue lies, why it is happening, and how you can fix it.
Since the dawn of civilization, mankind has always strived to grow and learn, to invent and innovate. Even today, business firms across industries seek to attain better performance, lower costs, and higher productivity. However, unanticipated machinery failures have resulted in extra costs, time delays, and numerous losses. This problem persists across all industries. Without preventative approach, enterprises are unable to optimize their operations. Further, siloed and disparate resources, limited spare parts, and lack of skilled engineers has left things unresolved, which calls for a comprehensive solution. HCL IoT Works Predictive Maintenance Solution is an IoT-enabled monitoring and maintenance solution that provides visibility to the imminent failure of any pivotal component of the machinery by using different types of data from the asset, using deep learning algorithms to predict a probable breakdown. It amalgamates things, data, processes, and people by providing measurable business outcomes for better analytics and behavior prediction. The predictive maintenance solution lights up an important, expensive business asset and continuously integrates multiple types of data onto an IoT platform. The system analyzes data using algorithms, which results in increased reliability and control over equipment life. The analyzed data details usage patterns and product life cycles. If a component is in critical zone, the system recommends steps to optimize, thus smoothing the maintenance process for minimal cost. An intensive care design thinking approach has been used to craft user experience and interfaces, making the entire process easily accessible. Moreover, the system allocates enough time to accommodate a local professional before the equipment fails. Workforce productivity increases by more than 50%. The system connects the various components and systems of an enterprise onto a single platform. The predictive maintenance is a ubiquitous solution having applications across every industry that uses heavy or expensive machinery, saving resources, money, and time. Welcome to the future. Say hello to HCL IoT Works Predictive Maintenance Solution. For more details, contact our HCL IoT Works experts today.
Okay, so now is condition-based monitoring. So what is condition-based monitoring? So before we go into condition-based monitoring, we must know what is condition-based maintenance. Condition-based maintenance (CBM) involve monitoring equipment performance with visual inspection, schedule tests, and sensor device to determine the most cost-efficient time to perform maintenance. CBM use sensor device to collect real-time measurements. For example, pressure, temperature, or vibration on a piece of equipment. This data allow maintenance personnel to perform maintenance at the exact moment it needed. So the example of condition-based maintenance is a mileage meter. So if you manage a fleet of vehicles such as in the transport or construction industry, you may be used to scheduling an oil change based on a calendar schedule, such as every 3 months, or mileage, such as 5,000 drive miles driven. But if you use CBM, your maintenance schedule may be informed by reading gauge that monitor oil particle. So this may mean changing the oil every 8,000 miles instead of 5,000 miles, or after 4 months instead of 3 months. The advanced monitoring will save costs on engine oil. Okay, so the next example is smart HVAC. So most buildings nowadays are upgrading to smart HVAC unit that can provide real-time reading of temperature and humidity. This is a form of CBM that utilizes diagnostic algorithm technology to adjust to control building temperature and alert management of any issue. This helps to prevent emergency shutdown or worse, fire damage. Okay. So next is condition-based monitoring. The only way to trigger condition-based maintenance is through sign of potential failure or evidence of reduced performance. The process for measuring, testing, and identifying the current state of an asset to find this trigger is called condition-based monitoring. Maintenance is performed based on asset health indicator. As machine health deteriorate to functional failure, various warning signs will present themselves. Condition monitoring aims to identify these signs as early as possible to reduce maintenance costs and increase the time to remedy the problem. Okay. The PF curve is a common way of visualizing machine health as it nears the end of its life, and the warning sign it will display along the way. So the PF interval represents when a warning sign is identified, potential failure, and the time remaining before the asset breakdown, that is functional failure. The wider the interval, the more time your maintenance technician have to respond and the less you will have to spend to remedy the problem. However, the system displayed early on in the PF curve are more subtle and difficult to detect. Okay, so next is the common types of CBM. First is vibration analysis. Second is vibration monitoring. And third is temperature tracking and measurement. So the advantages of condition-based monitoring are: first, increase uptime or reduce downtime. Second, reduction in or elimination of unplanned failure. Third, decrease maintenance costs. And lastly, increase asset life. So that's all for condition-based monitoring. So next we will watch the example of condition-based monitoring for electrical transformer.
An electrical transformer is a device that converts electricity from one potential to another by changing voltage levels. This improves the safety and efficiency of power systems by raising or lowering voltage levels as needed. In the commercial and industrial environments, they are used in the distribution and regulation of power across long distances. Transformer failures lead to power outages. What is consuming the power determines how widespread and how critical the outage will be. Electrical transformer failures are either mechanical or electrical in nature. The common causes of transformer failures include overload, line surges, connection deterioration, and partial discharge, among others. Anything that causes the transformer to become hot will result in breakdown of the insulation, causing it to become brittle over time, eventually leading to a failure. Condition-based monitoring with available technologies is key to avoiding a transformer failure and unplanned power interruption. They allow the maintenance team to detect early warning signs of failure, facilitate replacement, and allow budget planning for the company. These technologies include infrared thermography, which detects loose connections, crimps, and cable creepage. Structure-borne ultrasound, which detects loose windings and other mechanical faults. Airborne ultrasound, which detects arcing, tracking, and corona. Transient earth voltage detection, which detects partial discharge events that are occurring inside of insulating materials. External oil analysis, dissolved gas analysis. And, while not a technology, visual inspection cannot be ignored. Visual inspections help find contaminants, moisture, water, and pests such as snakes or rodents. This system will allow you to assess the criticality of assets and schedule frequent inspections on those assets that are deemed most critical. The goal is to find it and fix it before it fails by collecting and trending data over time to detect signs of gradual deterioration. This strategy overall is cost-effective and safer for the company as a whole. Another serious consideration for transformer maintenance is personnel safety. Many of these inspections require that the transformer be energized and operating under normal load conditions. Traditional inspection processes required personnel to wear personal protective equipment to perform the inspection of the energized transformer, resulting in elevated risk of an arc flash or electrocution accident. Following a condition-based monitoring system, using the previously discussed technologies makes the inspection process easier and safer to perform, as well as creating a cost-efficient use of labor. The key to transformer reliability is adopting a condition-based monitoring strategy that collects and trends inspection data over time. This allows the maintenance team to assess and monitor the health of the transformers. Fixing a problem before acute failure occurs saves a company time, money, and more importantly, eliminates power outages to the end user customer.
Okay, today I would like to discuss about equipment life cycle cost concept, as known as LCCC. But what is LCCC? Okay, life cycle cost is the total of ownership of machinery and equipment. And I must say that life cycle cost is very, very important for us in our daily life, because by applying or implementing life cycle cost in our life, it may prevent us from making financial mistake. Why? Because life cycle cost is an approach that assesses the total cost of an asset over its life cycle, including initial capital cost, maintenance cost, operating cost, and the asset's residual value at the end of its life. So now you understand why I say it's very important in our daily life, because when you're applying LCCC, you will make a research on something that you want to spend your money on, whether it is valuable in the future, or is it non-valuable in the future, or it will give you a burden or it not will give you a burden. So you will know if you're applying the life cycle cost. Okay, because I say it is very important in our life. Okay, let me show you one of example of life cycle cost. I think most of people, most of adults in our country have already bought a car, or they have their own car. Okay, so I give, for example, of the life cycle cost, I give you guys have to think of a car. Okay, think of a car. That is a okay. Make the car as a life cycle cost. Your life cycle cost. Okay. Okay. First of all, okay, the car's price tag is only part of the car's overall life cycle cost. It's only part, not the whole life cycle cost. Okay. So which means, after you bought your first car or any car or what, you have to consider the expenses of the car, insurance, for the interest of your bank loan, the engine oil change, you have to change your engine oil, and the petrol that you use to move your car. So and any other necessary maintenance to keep the car running. So this is also not adding if you want to upgrade your car or whatsoever. Okay, So this is life cycle cost. Okay, so it's very important for us to learn, and it's very I mean, it must to practice in our life. Okay, let's move on to more about this topic. Okay, so as I said just now, life cycle cost is very important for us as human being. But to be a great engineer, you have to apply life cycle cost so in your career. Because when an engineer applying the life cycle cost, so you can see, okay, I will show you the important for life cycle cost for an engineer. Okay, all right. So the first is it helps engineers justify equipment and process selection based on the total cost rather than initial purchase price. So, what does this mean? This proves that the engineer will do a smart buy. Okay. Okay. Second is, as you can see here, when an engineer applying life cycle cost, it will provide the best result when both art and science are merged with good judgment. So, what does this mean? So, when you are buying, when engineering is or whatever is thing that you do, you didn't make a result, you didn't make a decision, or you doesn't gain a result just from a one parameter. So like it say in here, when both are inside are merged with real, so means when a result, when they are producing a result, or when they are taking a result, so they takes both parameters, which is art and science, they merge together, and it will give a best result. Alright, third, it's help product suppliers to optimize their design by evaluation of alternative and by performing trade-off studies. So lastly, important of life cycle cost for engineer is a total cost of the product can be calculated over the total span of product life cycle. So just okay, as an example, you are an engineer. So for you found a solution. So the solution is buying a machine. So when you're buying a machine, you have to tell your company, you have to calculate for your company the total span of the product life cycle. Which means total. The example is like the product, the machine will be enough, will be good to use for 20 years. So this also the maintenance, the cost of maintaining the machine up to 20 years. So how much the machine can produce, how much the profit the machine can do. So this is a life cycle cost. So to be a great engineer, you have to make sure that you can use this life cycle cost in your career to make sure you did well, and you did well as an engineer. So, okay, let's see why. So, let me tell you the reason why you as a human being or as an engineer, you have to use LCCC. Alright, so as you can see here, the reason use LCCC, okay, because LCCC is very affordability study, which means everyone can just do LCCC or life cycle cost. Alright, okay, so we also as a student or before we become an engineer, so we can also take this opportunity to learn about life cycle cost or LCCC. Alright, so the second is the source selection studies. Alright, third is design trade-off. Fourth is the repair level analysis. Fifth is the warranty and repair cost. Six, suppliers sales strategies. So when you are using LCCC, we will have these six things in yourself, or when you're making decision, or when you are buying something, or you are about to set up a project or whatever, so you have the 6. So as you can see here, by doing the low life cycle cost also, it makes you a supplier sales strategies. So when you ask suppliers also, you can have a sales strategy for your product. So by using low cycle cost also, you will give your product a warranty and repair cost. So if you are about to sell your product, as an example here, as an example, you will develop or you will invent, right, let's say a mouse. Okay, a mouse. Okay, you can see here a mouse. Okay, when you create a mouse and you are applying LCCC into your mouse, you must know the ability of your product. So how long the mouse will do, and if there is problem, what is the most current problem or current error in your product. So you have all of this when you are using LCC. So when you have all of this information, you can give a warranty. Okay, let's see, we will give 1 year warranty to the user because you are guaranteed, because from your research your product is must be perfectly 1 year in a good condition. So this also will not bring a loss or losses to your company, but also it will be good, it will be give a good after sale market and will convince user to buy this thing. Okay, so when you are making a warranty, so there must be a percentage or maybe lower percentage that the user will give back the things to you. But as you can see here, you already know the cause, the problem that may occur, so it wouldn't give you loss, and it will also give a it will satisfy your customer, and this will increase your brand or your product. Okay, I think that is maybe a good or very long example. Okay, this is also you will gain repair level analysis, design trade-off, and success histories. Okay, this is the reason to use LCC, low cycle cost. Okay, let's move on to the next chapter. Okay, the advantage of LCC. Alright, okay. Low cycle cost is very useful to control program. So, like I said just now, when you are using LCCC, you are about to calculating, I mean, one thing, you can calculate the whole value of one thing. I mean, let's say, when you click mouse, when you're using low cycle costs, you will know everything about your product, the cost, the lifespan, the problem, the maintenance, how much you can profit, how much you can lose, how much you can guarantee, how long it will withstand, how you can convince your customer. So this is very good SCC. So now this is the advantage of SCC. It's very useful to control programs. So in case, okay, as an example, when you are about to making a program for your client, for your project or your mega project, so when you use LCCC, you will not waste a lot of money by making a program. You will only spend on reasonable, on necessary things only, and you will not waste the fund or the money that you get. Okay, second is a tool for making selection among competing contractors. Okay, when you are an engineer, so in case you are about to finding your contractors, okay, how you know which one is the best? You have to apply which one is the best and which one is the best for your project, and which one is will make the most benefit for you. Of course you will choose that. So this is important of the life cycle cost. So when you are applying life cycle cost, you can make a selection among competing contractors, because trust me, some contractors will give you, right, as an example, contractor A, they give you maybe not a very good equipment, a fast timeline, but much more cheaper. Okay, contractor B give you a very good substance. The timeline is a bit late, but it is much more expensive, just a bit. So think of a long term. If a long term, we need what? We need a very quality equipment. We need a very precise work which takes a lot of time. So which one do you choose? Of course, you choose contractor B because they use a very high quality equipment, object, substance to build something, and it takes a lot of time because they will have a good precision if they take a little bit more time. Okay, so maybe that's one of the best example to explain this. Number 2, and number 3 is for comparing the cost of competing project. So when you are competing projects with your competitor, you have to know how to beat their price, how to beat their timeline, how to beat their substance, equipment, and so by learning life cycle cost, you will probably will win the tender or the projects that you are into. So lastly is it's very low cycle. Life cycle cost is very useful in reducing total cost. It's not as an engineer, but as a human being, if you apply life cycle cost, it will useful to reducing a total cost. Okay, last slide. Okay, but this is the disadvantage of LCCC. Alright, so like normal things, everything have pros and cons. So this is the cons or the advantage of life cycle costs. Okay. Alright, firstly, when you are applying life cycle costs, maybe it will be costly and time consuming since time consuming. Maybe it will, since if you about to making a decision, maybe you will take a much more longer time than usual because you have to calculate everything about by using life cycle costs by using life cycle costs. And the second is cannot compare design alternative that have different benefit, e.g. reconstruct road versus reconstruct road with widening. Yes. Okay. So this is one of the advantage of cons of using low life cycle cost, because when you are using life cycle cost, so when you have to, it's hard when you have to, let's an example given here, reconstruct road versus reconstruct road with widening. So like I say, when you are applying life cycle cost, so this is the advantage. You cannot compare the design alternative that have different benefit. So when that road is broken, then you can fix it and you can start road with widening, because you have to use the same cost because you already calculate the lifespan of the road and so on. So if you use the widening, you have to make another calculation. So that's why is you cannot compare design alternative that have different benefits. So for the second point. So for the third point is the accuracy of data is doubtful. Yes, because okay, let just like I say, okay, this is the mouse. Let me talk the mouse. Alright, the mouse. So even you have calculated the life cycle, even you are the one who invent this, so how can you say that this mouse will last for 1 year, or this phone can last for 1 year? Of course, you can say by using a good substance or good component, good equipment to build this, but how? So it is uncertain. It's not say like we can't trust the low cycle cost 100%, but it's doubtful. Doubtful means it's not constant, or it's not a fixed. It's not a fixed result. So it might change. I mean, like, okay, as an example, okay, you ask your neighbor or your friend, oh, how good is Proton X50? They also say, oh, very good. Okay, the car is very good. There is no problem. If you 1 year, 6 years, wow, very good, very good. So, but when it comes to you buying the Proton S50, you use for 1 month, then boom, lot of problems. So that's why the accuracy of data is not full. So lastly is the obtaining data for analysis is difficult. So as I say to calculate a lifespan of, okay, if you create a phone, if you innovate a phone, so it's very hard to obtain the data of how long the phone that can be used, how long the phone, how long the phone will be good, how long the phone will be, how long the phone will stand, how is it guaranteed that the phone will not broken. So it's very hard. So I think that's the disadvantage of life cycle cost. But that's natural. Everything have pros and cons. But for me, I rather to have a lot of advantage of LCC, because actually life cycle cost will teach you how to be good in financing, making decision, or taking result. So you will make a decision, or you're taking a result not based on one one opinion. So you will take it by every parameter that you have, then you combine and boom, right? So that's all for my explanation for life cycle cost. So if you think so, I hope you guys will take this advantage for you guys to learn more about life cycle cost. Or if there is not much more information that I give, so probably you guys can take your initiative to Google or find any other platform asking lecturers about the life cycle cost. So that's all. Alright. So I will give you a video. So there's some 10-minute video after this. So you guys have to watch what is LCC in more details. Alright. Thank you and Assalamualaikum.
Your drinking water system is made up of many assets, from pipes and pumps to meters and tanks. It costs money to construct, install, operate, maintain, repair, remove, and replace these assets. A lot of money. Most likely, you don't have all the money you need to do everything that should be done within your water system. So, you should make smart choices about where you spend the money you do have available. Asset management can help with making these smart decisions. Asset management helps you determine how, where, and when to spend your limited money. It's about maintaining a desired level of service. That is, what you want to provide to your customers at the lowest appropriate life cycle cost. So what does life cycle cost mean? It's actually a pretty simple concept. It means the total cost of ownership of an asset, the purchase price, the cost of operating and maintaining it, refurbishments, and finally, disposal. But figuring out life cycle cost can get tricky. Sometimes assets that are cheaper to buy end up costing more over time, especially if the asset uses energy. Here's an example. Let's imagine you're buying a new pump. There are lots of options out there. All pumps of the appropriate size and power seem to do the same job, which is pump water. So why not just buy the cheapest one and save money for something else? Because what you really want to be thinking about is the cost of moving water over a period of time. A pump costs something to purchase. Then there's the cost of installing it, the average cost of maintaining it each year, the average cost of the energy needed to power it each year, the average cost of repairing it each year, and the cost of removing it at the end of its life. If the pump lasts for 20 years, those costs look something like... Whew! That seems like a lot. What if we go with a less expensive pump? Can we get our costs down? Let's see. So this pump costs less to purchase, and then there's the cost of installing, maintaining. The average annual energy cost to operate it is higher because it's less efficient, and then you factor in repairs and removing it. If the cheaper pump lasts for 20 years, those costs look something like... So the less expensive pump actually costs us more over time, and that has an impact on the entire system. There will be less money for other system needs. In fact, most of the life cycle cost of a motor or pump is the energy to power it, even though the tendency is to purchase based on upfront price. Not only will the more efficient asset often cost less in the long run, but lower energy use means lower heat and therefore often longer life. So, it's worth taking the time to pick a pump or other asset that will cost you the least over its life, even if it costs more upfront. So when purchasing an asset, it's wise to think about the long term. Paying attention to total cost of ownership helps systems avoid unnecessary expenses in the future and frees up money for other priorities. To find out more about life cycle costing and other financial tips for your water system, visit efcnetwork.org.
Okay, quite a common issue I see when people are planning projects, and especially when they're costing projects, is, well, that's a funny noise, the issue of life cycle costing. So most people, when they approach project management, they have this very short-sighted view of, look, the project and thereby the costs are hinged on getting it done. Cool. So we spend all this money and then it's done and now we're sweet. What I find the issue is that often not much consideration has been put past that point. And there's a lot of things to consider. So number one is who's going to own that stuff? All right. Who's going to get the benefits? Who's going to maintain it? No one can spell maintain, not just me. And who's going to pay for it? So there's a lot of questions that need to be asked. And often they're not asked or answered until after the project's been completed. And sometimes it becomes a bit of a handball. Look, no, your thing, now you pay for it, you deal with it. Or no one takes ownership and the great work we've done and all that capital expenditure just seems to be worthless. So what I advocate is to get all this stuff right here, especially before we make a decision. So to consider all these things in our decision making, whether we give the project go ahead or not. Very quick example for life cycle costing, and I'll just use on who's going to pay for it, for instance. Let's say our project was to buy a car. All right, so we do some research, we go in the market, we do some negotiations, we do some stuff, and we end up with a car. Cool. And the total cost of that project has been $20,000. Perfect, cool. Let's say that's all we had in our bank forever, $20,000. We would be able to drive it for 500 Ks, assuming it had a full tank of fuel. Then what? We can't manage the asset. We can't get any more benefits out of it because we can't put any fuel in it. Or if it breaks down, what are we going to do? So it's really good to consider these life cycle costings. So you might say, look, in the first year of having this asset, what are the things we need to pay for? All right, so we've got fuel at $10,000. We've got repairs and maintenance at $5,000. We've got, and that could include things like tyres and things like that. We've got insurances. That sounds like a legitimate expense. What else could we have? Stuff. I'm just going to call this stuff. And then we've got stuff. All right, so other stuff, incidentals and so on. So in the first year, we've got $17,000 of additional spend just to keep this thing going, to keep getting the ongoing benefits, which is, commuting in this case. We've also got depreciation, which I guess is actually part of the total cost of ownership, because let's say we spend it here, every year our asset is actually worth less and less and less. So let's say we can even add on $10,000 here for depreciation the first year. Right? It's a bit harsh, but it makes the maths easy. Right? So you can say, look, in the first year, this asset has cost us $27,000. Right? A book value of 10, cool, but it's actually cost us $17,000 to maintain it. And if we have to spend that every single year, all right, and we own this asset for, I'm just going to say 10 years because it's going to make our maths easy, that's us spending just on running that asset, the extra costs, $170,000 over 10 years. Then we consider the the book value, the loss, depreciation, which after 10 years, often vehicles are written off after 7 years from a tax perspective. So you might say, look, and then we've got something with zero residual value. So after 7 years, we might need to replace it. Who's going to replace it? Who's going to do that? This is a question I'm asking you because this stuff needs to be answered here. So please, do not go past this point in project selection before understanding all of these things. How I normally tackle it is I look at the useful life of the asset. How long are we going to be able to use this for? Then I calculate the life cycle costing. Then I make sure that we've actually got a budget to pay for this stuff. So every year we've actually got access to 17K. Then when the useful life is over or the contract is over, whatever the deal is, I say, do we have enough funds, put away to get a new car off that point? Also, I try and work out who's going to get those benefits, who's going to get to use the car. Generally those two are linked, but not always. Also, who's going to maintain it? Who's going to actually drive it to get service? Who's going to deal with all that sort of stuff? The non-financial maintenance stuff. Who's going to deal with the support calls? Who's going to deal with that? And who takes ownership of it? So who owns the residual value of the asset over time? So there's some of the considerations. So when you're starting a project or when you're considering doing something and spending money, don't just consider the acquisition costs, because as you can see, the acquisition costs may actually be quite a lot smaller than the life cycle costs, especially over a longer term.
Inventory control. So what is inventory control? So let's look at the definition of inventory control. Inventory control, also called stock control, is the process of managing a company's inventory level, whether that be in their own warehouse or spread over the other location. It comprises management of items from the time you have them in stock to their final destination, ideally to customer, or disposal. An inventory control system also monitors their movement, usage, and storage. So inventory control means managing your inventory level to ensure that you are keeping the optimal amount of each product. Proper inventory control can keep track of your purchase order and keep a functional supply chain. System can be put in place to help with forecasting and allow you to set the order points. Inventory control is a system that enables the business to control the inventory of items so that they are never out of stock, while ensuring that the cost of maintaining the inventory is the lowest. In other words, inventory control is a system that ensures that the items are always in stock while consuming lowest possible cost. Okay, next is inventory control. So what is the purpose of inventory control? So let's see. First, the purpose of inventory control is to ensure that there is no out of stock scenario. Second is to maintain proper record of the inventory. Third, to hedge against price increase. Okay. Next is, what is the types of inventory control? So let's see. There are several types of inventory control. First is raw material. Second is work in progress, which is WIP. And then last one is finished product. So let's see one by one. So the first one is raw material. Raw materials are the materials a company uses to create and finish a product. So raw materials are typically unrecognizable from their original form, such as oil used to create shampoo. Other examples of raw material in making t-shirt has components that include fabric, thread, dyes, and print design. So next is work in progress, or WIP. Is inventory refers to items in production and include raw material or components, labor, overhead, and even packing material. So Work in progress inventory or WIP inventory can also call semi-finished goods. They are the raw materials that have been taken out of the raw material store and are now undergoing the process of their conversion into the final product. So these are the partly processed raw material lying on the production floor, and they have also not reached the stage where they have been converted into the final product. So lastly is the finished product. Finished products are items that are ready to sell. It is the final product obtained after applying the manufacturing process to the raw materials and the semi-finished good. They are sellable and their sale contribute fully to the revenue from the company corporations. So for example, the finished product is t-shirt, snack, handphone, and many more. So that is all the types of inventory control.
Inventory control, definition and objectives, presented by eduxit.com. In this video, we are going to learn inventory control, definition and objectives. Inventory control is a system that enables the business to control the inventory of items. So that they are never out of stock, while ensuring that the cost of maintaining the inventory is lowest. In other words, inventory control is a system that ensures that the items are always in stock while consuming lowest possible cost. The inventory control system serves the following objectives. Ensure that there is no out of stock scenario. That means always there is stock maintained. Minimum optimum levels of inventory to eliminate excessive costs. To facilitate scientific basis so as to plan the inventory requirements. Maintain safety stock levels to compensate the fluctuations in demand for the product. You can see that the stock never goes out of the green line here. It's always above. That means as soon as the stock reaches the level represented by the green line, it's immediately replenished or refilled so that it is brought to appropriate levels. This ensures that the stock is always maintained and it never goes out of stock. Maintain optimum levels of inventory so that the deterioration and obsolescence are least. If the business is maintaining some perishable stocks, it is possible that there will be deterioration of these items. And if the business is maintaining products which use advanced technology, then it's possible that very soon these products will become obsolete. And if the business maintains huge stock of this, then it's likely to run into losses. Maintaining a smaller stock will enable the business to ensure that the stock is finished before it becomes obsolete. In case of perishable products, the business can finish the stock before it deteriorates. Maintain proper records of the inventory so as to safeguard against stealing, loss due to leakage, or loss due to pests. And also to ensure that the stock is ordered to replenish it in the right time. That covers the definition and objectives of inventory control. Thanks for watching. eduxit.com is started to promote effective and efficient learning process to help the students with their learning requirements. To watch all our videos, please subscribe to our channel. Also, please click on the bell icon to receive a notification as soon as a new video is published. Please click on the like button if you like this video. Thanks for watching.
Economic Order quantity. Economic order quantity is defined as an inventory order quantity that reduces the total cost of inventory management. Its goal to reduce the whole cost of the inventory system, which includes things like holding costs, ordering costs, setup costs, and shortage costs. When the graph shows as the holding cost increases, the ordering cost decreases. It's because the more inventory we have on hand and the more product we order, the lower cost of ordering becomes. Meanwhile, as the order size grows, so does the holding cost. However, the cost of ordering is reducing while the size order is increasing. The economic order quantity happens when the holding cost and ordering cost overlap as shown at the bottom. Next, there are 4 formulas involved in economic order quantity. First, the economic order quantity equation represents Q star, which is the square root of 2 times C times R divided by P times F, where C stands for cost per order event, R stands for annual usage in unit, P stands for purchase per unit, and F stands for holding cost factor. Second, there is the number of order per year equation, which is written as N. N equals R, which is annual usage divided by Q star. The third equation is the expected time between orders, which is represented by T. As the equation written, T equals the number of working days per year divided by N. And finally, there is the cost per order equation, which would be C plus P times Q star. From the example, you can highlight the keywords from the question, which is the annual usage of Fizzy-Cola drinks that needed is 5,200. Next is the purchase cost per unit is 50 ringgit. The ordering cost is 10 ringgit, and the holding cost factor is 26% or 0.26. So the question is asked, how much should the restaurant order per month to balance between storage and ordering costs? First, you must find the economic order quantity, which is the Q star. From the question earlier, you can use the Q star to find the economic order quantity value, which is 89 units. Second, we have to find the N value, which is the number of times to order per year, which is from the answer that we get is 58 times per year. Next, we have to find the expected times between order. From the question, we need the total number of working days, where we can assume that 1 year is equal to 365 days, meaning we have 52 weeks in 1 year. So we can assume the number of weekend is 2 days, where we don't work at that time, which will be equal to 2 times 52 weeks, equal to 104 days. In Malaysia, we have about 30 national holidays, and assuming that in Selangor state, we have about 4 days of holiday. So minus the 365 days to the total of number that we are not working, we will get the total number of working is 244 days. So using the number of working divided by N, which is 58 times, we get 4 days. Lastly, we should find the cost per order answer. So from the calculation, we can get that the cost per order answer is 4,460 ringgit. So to conclude for this example, an order of 89 units to be placed every 4 days, which is 58 times per year in order to optimize ordering and storage costs. Each order would cost 4,460 ringgit. So in conclusion, maintenance management needs systematic actions in order to extend equipment life and ensure optimal production capacity. In addition, inventory management requires overseeing the availability of raw materials for production. It takes a structured approach to ensure that stocks never run out and are supplied on time, all while keeping order and storage costs to minimum.